Layout. All right. Hello, all, and welcome to session two. Just a quick reminder, we have this recording in case anyone can't make this, or something comes up, connection drops, whatever. But we have these recorded and we'll send it out to everybody afterwards. Quick reminder before we get started is just remembering how all the controls on Teams work. So you have a window that you should be able to see my screen and me right now. And you've got the toolbar across the top. The big ones that we have to look for is the camera button. Love it if you would have camera on during this just so it's easier. I can see what you're doing and we can talk over things and it makes it less like talking to a wall. But if you need to have it off, that's fine. If you need to speak or share anything like that, you should be able to unmute your mic at any time. And you can just ask me a question or make a comment in some ways. I'm going to try to keep this as interactive as we possibly can. And then other buttons are kind of the how do you best communicate during this. So if you're stuck, you can't see something, anything's going wrong with technology or anything like that, if you hit the raise your hand button, what that'll allow you to do is that'll allow me to see it. I'll stop and talk through anything you need at that one. So that's kind of your emergency button. If you have a question that you want, if you want to just make a comment about something or share a resource or anything like that, just kind of everyone to see, but you don't need to really discuss, that's perfect for the chat. You just hit the chat button, enter that in there, and you can talk through or you can add anything you want to the discussion. You can go back and forth as we're going along with this as well. If there is, however, something you want to talk in depth at the end, so we're going to have a moment where we can talk over things at the end of going kind of deeper, I call it. If you want to have something to focus in on for sure, put that in there and we will make sure we discuss those. If we don't have anything entered in Q&A, I've got a couple things to talk about to dive deeper, so it'll be presenter's choice at that one. But the Q&A is really for if you have anything that you want us to discuss or group or spend some time on. So hopefully that all makes sense to everybody. With that in mind, here's the agenda for today. What I want to do is do a quick recap on last webinar, last session for stages 1 and 2. Just kind of give you a chance to ask any questions or share some thoughts as you're thinking about that. Then we'll go into the meat of today, which is talking about stages 3 and 5. And then after we get done with those, we'll have that time for a deeper dive. And like I said, based on how you all are thinking about this, I really want this discussion to be useful for you. And then we'll do a quick wrap up. So with that, we should be in good to go on that. All right, so let's get started with things. Let's go back to last week. We talked a little bit about stages 1 and 2, and just a quick reminder of that. You've got these kind of things that you're trying to do in those 2 stages. So the first one is called task, and what you want to do is introduce a phenomenon of some kind, then get kids creating initial models that represent their thinking about how that phenomenon happens, so why that happens, and then give them a chance to talk over the gaps in their models. And what that ends up doing is creates a need for them to learn more. Which then bops you into the next stage, which is ideas. And what we try to do is then identify some ideas that are useful, not answers to the phenomenon or an explanation of that, but what would be the DCIs or cross-cutting concepts, or if you're in Texas, recurring themes and concepts and practices that might be useful on this. So there'll be different combinations of those, but all 3 of those dimensions will be in there during the investigation in some way if they're not formally in a written version of the ideas. So that's what we talked a lot about last session. Does anyone right now have any thoughts or questions about those two stages that you'd like to share, feel free to unmute yourself and ask if you'd like. Oh, feeling good about this. Works for me. If something pops up as we're going along and makes you want to think about that, feel free to let me know and we'll talk more about that. So let's go on to today's big session there is, which is talking about kind of the middle part of an investigation, which is stages 3 through 5. So remember, there's kind of this whole 7 stages. Kids don't really need to know about this. This is for us as educators thinking through what we're trying to do and creating a learning environment that's kind of conducive to learning. So the focus on 3 and 5, hold on, I gotta let somebody in here real quick. So the focus before stages 3 and 5 become the plan, the do, and the share stage. So what I was going to do is kind of go over some of each of these, what they look like, some of the design decisions that we have in this, and give you chances to answer questions about any of these things. So let's dive into these things. So the first thing we do is on the plan stage is really give kids an opportunity to create a plan for what they're trying to figure out, and then give them an opportunity to get some feedback from us as teachers. And there's some different ways that you can go about doing this that really make that a little bit easier because they're novices. And when you're a novice, it's hard to figure out things perfectly the first time. So there's some things that you can do as a teacher to kind of help support that. So let me give you an example of what that might look like. So we were talking about the Mexican wolves in Texas last time, right? So we were talking about that idea of Mexican wolves being reintroduced into Big Bend National Park, but there's also bighorn sheep there, and we're trying to figure out a little bit about, well, what's going to be the right balance to have stable populations when you have kind of a predator-prey relationship going on in there. So in this case, what students are going to be doing is, since they can't go out and physically collect data on the sheep, wolves, and that kind of stuff, they're trying to make a kind of a prediction or advice about what's the best way to do it. What we have them do is use a simulation to allows them to test their ideas. So this simulation here is called Wolf Sheep Predation. It's a NetLogo model. I'm going to tell you how to get there so you can actually see this. So if you open up a new tab on your browser, I'm going to put this website into the chat. You can just click on that. So when you click on that, it'll bring you to a screen that looks like this, NetLogo Web. I'll give you a second to do that. Once you get there, you want to hit on the left, kind of, I guess that big box that says NetLogo Web. You can also download this onto computers and all that kind of stuff, but I've always found the web version works just fine. Runs on Chromebooks, all of that kind of stuff. So click on NetLogo Web. When you do that, and this, as you see, it's absolutely free. When you do that, you'll get a kind of a model that shows up. And up in the left-hand corner, it says search for the models library. And it brings a random one up every time you open this. So what you want to do in the search bar, that little drop down search bar, it's also typable. Just type in the words wolf, sheep, predation. You'll probably find it just with wolf. But if you get all 3 of those words in there, you'll definitely find it. Give you a second to do that. All right. Once you have that model, it should look something like this, except you're going to have a big black box instead of the green and brown and white and black spots. Okay. So to be able to see make it look like make it look like it does on my screen, you hit the button that says setup. It's a big blue button in the middle right there, and just hit setup. Then what you can do next to that is you hit the button that says go, and that runs the model. And you'll see a bunch of things moving around, and you'll see a graph starting to show up. Now, what happens with NetLogo models? They're designed to be agent based, which means that each of those little spots in that large area on the right is programmed to do something based on the rules of these models. So you've got wolves in there, you've got sheeps in there, you've got grass in there. And each of these agents, you call them, each of those basically boxes follows a specific rule in the program. So you can mess with all sorts of great things on this. So if you look on the left side, you've got a model version where you can change this, where you can include sheep, wolves, grass, and then you can change it to a couple other models. So if you do that, all you have to do is change the choice box there and then hit setup, and the new set of rules will set up into your model and it'll run following those rules. Now, with any of those model versions, then you can change a bunch of different factors, like the grass regrowth time. So that's basically how fast grass regrows. So you can simulate time when there's very little water or lots of water or very cold temperatures, and by saying the plants are not growing as fast. You can set your initial number of wolves that you're putting into your ecosystem. And you can also have your initial number of sheep. Anytime you change one of those sliders or type in the exact number, you have to hit the button setup to reset the model. Then when you hit go, it starts running. Okay. Then also on the sheep and wolf settings, you can set in there how much every time a sheep eats some grass, how much energy do they get from doing that? So you can simulate if you've got really nutritious grass or kind of like in a drought where it's pretty bare. And you can also say how many sheep in that environment are going to produce in any given time. Right now it's set for 4%. Same thing with wolf. If they're eating like big, thick sheep, they're going to get more energy versus less one. And then you can also set how often they're all reproducing. You can also show their energy and that kind of stuff in that. So take a minute real quick and just kind of play with this model, right? So hit the setup and the go button, see what it does. I'm just going to give you a second to play with that so you can kind of see what's going on. Yeah, play, try to break it. There's nothing you can do to break it. All you have to do is re-hit the setup button and hit go again. So play with that thing for a second, if you will. If you're stuck at all, you can unmute and ask me a question. Oh, so on the display on the energy, if you click that little icon up and then hit reset up, you should get a number that overlays on each of the animals, I believe it is. Yeah, the way that they do it in the shows, I don't usually use the show energy feature very often when I'm using this with students. I usually just leave it off because it makes everything cluttered. And what it ends up doing for you is it allows you to track individuals, right? So anytime where it says go, you can pause that and restart it again without doing the setup. So if you want to say, okay, what's the average energy of all the wolves in here? You can stop, count them up, do an average, or you can pick a wolf and follow it and that kind of stuff you can do with that kind of thing. And no, it does not do an energy pyramid as a final output. So what you do end up getting is just population sizes. And so what you're looking really here is at the back to the kind of the original question is the stability of the different populations in the ecosystem so they can fluctuate up and down. But really what you want, nothing is going in stick and are dying out in this area. So Your hope is to try to figure out, well, what is the things that break it, right? So has one organism die out or both? Does it mean you need a lot of grass regrowing? Do you need to have a lot of energy from grass? Or does that matter? Is it the number of wolves that are in there at any one time? Like these are the things that kids can start kind of testing their ideas about. So they have to kind of set up controlled conditions, so to speak, with the models so they can start comparing stuff. Okay. So hopefully everyone's got kind of a chance to play with this. So this is kind of really what I do to get kids started with this is like on this exact investigation, spending a minute and saying, okay, we're not going to be able to go out and collect wolves and put them into the Big Bend environment and see what happens. And that's not actually a really great thing for us to do anyway if we're trying to conserve, right? So we're trying to make estimates and predictions based on what we know about how things interact. So scientists often use models like this to do that. So introduce it that way, let them play with the model and see if they can break it, right? And figure out all the things they can do. Then I tell them to close their laptops. And then I have them as a group fill out an investigation plan, right? So back to this is I want them kind of really thinking about what kind of comparisons they need to make. So when they come back to this, then they start thinking about, okay, what question am I trying to answer, right? What is the thing that we're all doing here? What observations or measurements? So of all that information on that in that simulation, what am I actually going to pay attention to, right? So like, what am I going to record? When am I going to get those? Is it the beginning, the middle, the entire time? Is it a difference? Then how am I going to collect those observations? So what conditions am I going to set up, right? Am I going to set up this population with this, this, and this? And then finally, once I have those observations or measurements, what am I going to do with them? How am I going to make sense of them? How am I going to analyze them? Okay. And then for you as a teacher, when a group has this kind of figured out, you can go over and you can sign off and give them feedback on, hey, you might want to thought about this. Hey, you might want to thought about that. My goal here is not to have this perfect because you can learn a lot by making mistakes and it's really easy to change things as you're going along, but just to have them kind of have a productive start. So what I usually look for is if they're going to be able to get any kind of usable data. In this case, almost everything's usable, and they can rerun them so fast. So I'm kind of just like, okay, you got a plan, go get them, and then they'll move on to the next stage. So that's the example how you can do this with a simulation. Now you might be wondering, like, okay, lots of computer stuff and things like that. I think we mentioned that last time we were talking about this. So the way we design these is really around phenomenon, right? So anytime we have a topic, so like ecosystems, right? Ecosystems is a hard one to do an investigation about in the confines of the classroom. So we ask this kind of our question to ourselves, can students collect their own data, right? So if we got a yes, no on that question, we run down this flow chart. So if they can't collect their own data at all, the next question becomes, can they use an existing data set? If they can, we do the investigation. If no, we're going to pick a different phenomenon, right? So that means we've got to be able to access actual data for things. If you get a yes on the first one, collecting our own data, we go with, can you do it with a physical equipment? So the first priority always is physical equipment. If you can do that, yes, you're good on your phenomenon, go. If no, that's where we get into the simulation. Can we use like a NetLogo or a PhET simulation to do this? And the reason we focus on these simulations is because it doesn't tell them the answer, right? It's not like click everything into the right boxes, and then that tells you your correct way to go. Now you can move on. So it's not like a game. It's more of can I use this as a tool to test variables in that? And PhET and NetLogo does a very good job of that. So we'll use both of those on that. So basically, if we can find a simulation and it'll work for that, yes, we do it. If no, we pick a different phenomenon. So that's kind of like how we think about this. So let me show you a couple of other ways, more of the kind of the physical equipment and the existing data set. So here's another example of a physical equipment kind of investigation. So this one's called land sailing. And the idea is you introduce people land sailing on the Mojave Desert, and they're moving back and forth And students then have to start figuring out about how direction of wind and speed affect the motion of these sales carts. So we have all of these tools that they can use to do this. So let me show you a picture of some students, what they set up here.
Stopwatch. Ready?
We're doing 10 seconds
From when you turn it on, right?
And then we'll go high first.
You want to do high first?
Yeah, that's how I have it written down.
Okay.
High, medium, and then.
Okay. Ready? Go.
Right. And that was their first round, and they're like, oh, wait, why is this not like, because they have to realize there's a balancing of forces kind of thing. So it gets really interested when they start doing that. So when we have an investigation with physical materials, the investigation plan looks a little bit different, right? So it's still asking what kinds of questions, what observations or measurements you're going to collect. I think you might have heard of them in the video saying, yeah, that's what we wrote down. How you're going to do that, show me a picture of how you're going to set this up, because the picture really helps you as a teacher to kind of know what they're doing on this. And you can also make sure they're going to be safe, and then how they're going to analyze those. All right. Next one is, okay, say we're studying like the fossil record, right? So that one gets a little tricky. Like there's not really a simulation for that. There's not really anything physical, but there are great data sets. So on this one, what we're asking students to do is thinking about how the amount of biodiversity on Earth has changed over time based on what we see in the fossil record. So in this case, we can give them an Excel spreadsheet. So there is some amazing databases that are free to use. And we downloaded one of these and kind of cleaned it up so it's a little bit easier to read. But it's basically an Excel spreadsheet. Then they can do frequency counts by all of these years. And it just represents which families, phylums, and classes are represented in the fossil record at any one time. So it gives you a way to start digging down on how much biodiversity that's actually there. And each of those tabs then is a different phylum on that part. So they can say like anything in green means it's been found in the fossil record. A red 0 means that it hasn't. A yellow means it's assumed that's there, but we just haven't found a good example of that yet, but we predict it's there kind of thing. That's when you have like a missing chunk between time periods. So when they do that one, we can have them set up this one where they're testing these different hypotheses of, hey, did the biodiversity go up? Has it stayed the same? Has it gone down over time? Right? So those are kind of your 3 big hypotheses. And then you can say, okay, how has biodiversity changed? If it's one of these, what should I see in the fossil record when I do those frequency counts? I do those, what would my prediction be? Right? And then that can kind of start thinking about which best matches with what we see. Once again, you can sign that off and talk through that. Another example of one you can do with a data set is embryo development, right? So we're not going to be collecting embryos and watching those of different kinds of animals, but there is amazing data sets. There's entire journals that are dedicated to mapping out the developmental sequence of different kinds of animals. So in this case, we frame it around that, around how well does the process of vertebrate embryonic development support the third descent with modification is the big question. In this case, they have all these little cards, and we have these different animals, and we took actual images right out of journals, and then they can line those cards up and compare what things end up looking the same, how much they're different, how similar they are, based on how related they would be. Once again, we can start testing hypotheses. Like it's very well supported, right? So we see this, and it's not what would we predict to see in this data set, what would we not be able to see? And then that gives you an opportunity for your kids to start planning out why are they looking at what they're looking for. Okay. So with that, I'm going to stop there real quick. Does anyone have any thoughts or questions about the plan stage at this point? Anything going on? I'll give people a time to kind of collect their thoughts. What do you all think about this?
Something occurred to me as we were looking at that website.
Yep.
Do they have, I'm sure we could find things, but like, let's say I was trying to give them something not quite the same as one of those activities, in order to like prompt them so they could actually then they could get some background knowledge and research in order to be prepared, right? Uh, I'm trying to think of the best way to do that. I can think of some resources, but does that website for each of those scenarios have some sort of like background knowledge for the educator
Yes.
to help them?
So,
Okay.
well, it kind of will tell you, it'll tell you the rules of how it's been programmed on NetLogo.
Okay. Yeah. Because what I was
Right.
looking for is, I don't know, I'm trying to
So
think what I
scroll,
just. Yeah.
so scroll down, there'll be some boxes on the bottom, will say model info.
Okay.
And then if you open that, it'll tell you how it's programmed and how everything is represented in there in just
I
plain
think I
language.
think I accidentally closed the site. Let me go back to your link, I guess. Hold on. Ugh. But that's what I was looking at the different things because I was trying to see if there'd be a way for me to find topics that I could, but then I might have to do a little background to make it fit within my curriculum, let's say.
Yeah,
Or what
and-
what my goals are.
And that's always the hardest thing with this. So like when we're building out this, that's that flow chart, right? So not everything can be taught through investigation, right? So often when we're thinking about this and we see a standard, so this one has to do with like changes in populations due to changes in ecosystems, right? So it becomes kind of complex to make up these things because you first have to say, okay, what's the phenomenon where you would be able to learn that idea?
Oh,
And
there
then
was one
do
about eye development. Sorry, there was one about eye development and adaptation, which is something I could conceptually very much see myself using in my Zoe class.
Yeah,
But then trying to figure out what, like, I'm positive they're going to need some background knowledge to figure out, like, what is the experiment trying to set up? So that was the one that looked complex and interesting to me.
yeah, and play with it for a second because honestly, the way the Net logo ends up being designed, it's designed to be able to have like here are the tools that you can change, but you can basically test variables, right, in a complex system of things. And what I usually do with the kids, what I found is the best is like what I just had you do here is I have you open it up. Like, so after we've talked about some ideas from that idea stage, I just have them open it up and play with it for a minute. And then they'll ask a bunch of questions like, what does this do? What does this mean? I don't know, try it. Or if they still are stuck, it's like, then you can explain why that happens. And if you give, I call that kind of like a tool talk is the best way to talk is describe that is you put those things out there, let them play with them for a minute so they can figure out how that works. It's the same thing with the physical materials. Like the hardest thing kids do is figure out how to design an investigation from nothing. Right. So
I
if you
guess
just
my
say,
question is more from a teacher point of view with that looked like I'm trying to find that model again. Like it's a fairly complex looking model, which feels to me like I need to understand the research behind it so that I can tweak it, right? Or tweak what I'm introducing from the teacher knowledge so that I can be in a position. And I
that would
didn't.
be that would be the model info toward the bottom, right? So you got to scroll down. You've got the whole box and set up. And as you go down, there'll be kind of 3 drop downs.
Okay.
One will say model info.
Okay. Because I saw model programming. Okay, now I'm trying to find that same model again. Sorry. I just ran across it and I was like, because I was scrolling through there. I'll mute myself. I'll keep looking.
You're great. Other questions, thoughts on stuff like this going on? Things you've noticed in doing kind of inquiry-based things with students or having them plan carrying out their own investigations, anything like that?
As weird as it sounds, the flowchart was actually a good visual to whether or not that would be a good phenomenon to like push forward on. I have never really thought about it like that.
It's really hard because
Especially
you get stuck, right? Like I mean, especially if you're doing an investigation of a phenomenon. Now, if you're doing like a unit around a phenomenon, you can do like mini investigations in there. But that's the hard part of reaching these standards this way is how do you actually have all of this be coherent in a way that kids actually get to do something and they're just not told the answer? Because there's tons of resources that tell you like teach you the concept by doing the activity in there, right? And then that's just that we lose the exploration of it. It becomes, well, that, yeah, of course that's the answer versus them having agency to choose and engage in the practice of actually planning investigations. But also the nice thing about this too is like over the years of doing this, it really kind of draws attention to how different fields are, right? Like there's a reason why we have different fields in science. It's not just all science, right? And it's because there's different phenomena you investigate and explore and try to make sense of. You have to use different tools and different methods of investigation, right? So like some fields love simulations, some love experiments. Other fields never do an experiment at all, right? Everything, some is just field work, some of it's not, right? Like it's very interesting how that ends up playing out. But you've got to be careful about what phenomenon it is. It's not only that it's interesting, but can you act? Is it actually doable to collect data on it in some way, or get access to real data, right? Because that's the other one is we'll end up giving summaries to people of stuff, right? And then or like, oh, this is the trend, or here's an example, and look, that's a predator-prey relationship. Okay. But that's not really figuring anything out, kind of thing.
Sorry, just a quick note for the math person. I don't know how many of you have scrolled down. There's like some physics and math things. I'm just scrolling.
Yeah, there's definitely some ones of that they've been doing in this. It's a whole library, so it's a whole group of people that make these, right? Free. You can program your own if you want to. I've never actually gone about doing that, but it's a relatively simple programming language, and you can go in there. So there's folks in math doing stuff, and they like to really focus on kind of complex systems because this is what agent-based stuff's really good for, is things that don't have phenomena that emerge from individual behavior, right? So like that's the thing about an ecosystem. You've got individuals doing stuff, but when you look at them together, these patterns emerge. And NetLogo does a really good job of helping you do that, but you'll never get the same simulation twice because there's a randomness to it. Just like in the real world. So you end up doing, like, if I repeat this 3 times, you'll come up with 3 different kinds of things. So you have to start thinking about, is this a trend I'm seeing? Are these that are consistent? Was this a one-off randomness? Like, it gets to be really interesting on that kind of front. Sound good? All right. So you've got those different ways on, so physical, simulation, existing data set is kind of the 3 you'll have there. You'll have different kinds of planning guides that you can use with students, and give them chances. Always do the tool talk first, right? Let them play with stuff or see other materials, ask them what you might use this for, have that out there before they start planning. Let them plan, give them some feedback. Once again, I wouldn't say making sure. The only time I would be really heavy on making sure they have a really solid investigation that they can follow, investigation plan they can follow, is if it's something really time consuming or very expensive to do. Like I think of like chemistry often is we only have so much material or something like that happens. But if you're using a simulation or something like that, you can rerun an entire thing in 10 minutes, right? So it's not that big a deal if they make a mistake, and they'll actually learn more from those mistakes than having a perfect investigation from the onset. Okay. So once plan and do kind of blend together a little bit, kind of depending on your class periods, how long you have. What I often try to do is plan and do in the same 50-minute period because it just tends to work out the best. So like task and ideas, I'll do in the first day, 50 minutes, and then plan and do in the next day. And because that works out pretty well, it ends up being about 20 minutes for them to play with the materials and come up with a plan, but every group will be slightly different. And then the rest of the period is for them to go ahead and carry out their plan and answer the guiding question. What's also nice about that is it gives you a defined stopping point. So like the end of the period, you've got to have our data collected by this, right? So it kind of puts a sense of urgency for students. There's 2 little tools that we use to help them kind of make sense of that. So what I usually do is when I say, okay, go, you're ready to go, I'll tell them to flip to this page where it says collect data. And there's just a big box where they can write down observations and measurements. Some kids will jump right to making a data table there or a graph. I usually just say it's fine if you want to do that, but right now you can just keep track of what you're noticing and seeing or things that you changed. It's kind of more of like a journal spot at that point. So once they get done with collecting their data, then I push them to move to analyzing it, right? So you've got all this data and observations. What can you do to start looking for trends or relationships or differences in variables? How can you show that? And that's where they start thinking about, okay, graphs would be useful to show like a relationship between two variables. So I could put one on the X and one on the Y. Or maybe I'm doing something that change over time. I can do a line graph to see if it goes up or down. I can compare two groups on the same line graph and that kind of thing. So the big thing is what they're doing is trying to answer their guiding question at this point. So it's not so much that I've just analyzed data for no reason. They're trying to figure out, is there a difference between groups? Does this factor actually matter? Does it not matter? Did my prediction match did my actual data match my prediction based on my hypotheses? Those are the kinds of things they're doing. So at the end of this point, your goal is hopefully they can answer the guiding question at this point. So there's a kind of like, okay, what have I figured out? I figured out in the case of wolves, you've got to keep the number of initial wolves down, and can only release them when grass is growing rapidly, right? If you don't, that kind of like that double whammy there will have the sheep population die out, right? So those are the kinds of things that you start seeing or having come up with an answer on that. Okay. So that's kind of the do stage. A good thing for you while they're working. So one of the things I would offer as a piece of advice, as students are working, you've got everybody working on things, right? So you'll have 5, 6, 7 different teams working on stuff. And one of the easiest things to have happen as us as teachers is we'll go work with a group and we'll end up spending 40 minutes with them or 20 minutes with them because they're asking questions and they may be great questions or they get stuck. And then the next thing we know, we have only talked to one group in the entire class period, right? Like I'm super guilty of that. I'll start chatting with somebody. So my advice to you is use this technique. It's called 2 questions, a nudge, and a goal. And it's designed to make sure you're moving fast, but giving the kids the help that they need. So it's designed to be able to check in 3 minutes. So that way, if you start doing the math, like, so that's 8 groups, I can check in with everybody in about 25. And then I can go around a second time and see them. And so the way this works is you come up to a group, you sit down with them. I always say sit down, get on their level, especially I'm very tall and very big. So I end up looking down on people, which is kind of scary. So sit down with them. And then I just ask, hey, can you tell me what you all been doing or thinking about? And so that's question 1. And then what happens is one student, usually the kind of the dominating personality of the group, will answer that question. And that answer will reflect whatever that person who answered it was thinking. So you don't really get what the group was asking. So you ask the second question, would anybody else like to add anything? And then a different student adds that, and that's usually more of what the group was talking about at that time. So then after you kind of know where they're at, then you offer your nudge, which is, have you thought about this? Or I'm seeing you do that. Or, ooh, I'm wondering if you have remembered to do these things. And then they'll go, oh, that's a good one. And then you set them a goal. Okay, I'm going to go check on the other groups. When I get back, I want to see your trials done. I want to see you have a control done or whatever you need to do. And then you move on to your next group. And just following that 2 questions, a nudge and a goal, you can get in and out, get people unstuck and help them really move through this as you're going along on that. And then there's some other little techniques that you can do as well. If you're noticing like every group is having trouble, you can bring one representative from each group over to you and you can tell them, hey, here's a hint for your groups. I'm seeing everybody do this, try this, and then send them back. There's some other little different things you can do with that. But what you're trying to do here is kind of help steer them in productive ways. And when they get blocked by some obstacle, removing that obstacle the best that you can. Okay. So with that, open forum, thoughts or questions that you have about the do stage. I can see, Dawn, I can see your face looking a little puzzled right there. Any thoughts or questions? Doing okay? Cool. Everyone else doing-
We get, if we attend all these live, we get materials. I mean, I know you send us, this is available for download because I'm trying to listen and not, I am writing notes, but I'm trying to also be engaged.
I gotcha. Yeah,
Because I have a tendency if I start writing notes or something, then I miss something else happening.
oh yes, that's always the problem. So yeah, you'll get the video of all this and everything.
Because like I was like looking at those question things and thinking, I do use some of those skills, but when you guys do this, do you ever write like not quite a script, but like a pacing guide for yourself? Because I've done this before, so I've got like a list of questions I need to make sure. It's like I don't know how to word this. But I guess is there materials that we get so that I have like a hard copy of this that I could then modify for myself?
Sure.
Okay, that's yeah.
There's always
Other
lesson
than
plans,
that-
sample questions, and things like that. The hard part, like what I've always found too, though, is I don't know. I can't predict what kids are going to ask me, right? And it's just trying my best to make space so they have a chance to ask me things.
Well, and
Right.
I would say I worked in like a teacher group where we designed lessons, but then we also went out and tested those lessons. But we came up with like a class time pacing guide for the activity, and then we had and then working on as a group and experience anticipatory questions that we either anticipated ourselves, or gathered from the field.
Yes.
Because it helped the poking, right? The prodding, it would
Yeah.
help to create things like that.
Yep.
Because I'm just
So-
imagine trying to engage this in a classroom for maybe in the first year, right? Or like working and refining and like reflecting as a teacher of what went well or didn't go well, or what can I do? Or was that me not engaging them or guiding them or giving them the scaffolding, or was it them not participating?
Yeah. And then if it's them not participating, how do I get them to participate? So what was causing that problem? Yeah. I completely agree. That's the I think that's why I like instructional models the most, right? So once you get you can start thinking of these as routines. And once you see the routines, you get like 4 or 5 variations of typical things. And once you've seen those 5 things, like, oh, we're going to get to the stage and someone's going to be stuck on this. I know it. Or they're going to have trouble with this. And you can decide whether to mention it early or just be ready to hit it when it comes up. But that, like you're saying, that's the gift of teaching is we have to do these things so we can experience them and know how people are going to react to those things. But yes, we definitely put teacher notes and all that kind of stuff as much as we possibly can without it becoming a 400-page lesson guide, which is that nobody reads, right? So it's this fine dance of like, how much do I give and how much do I not, or what's overwhelming and those kinds of pieces. All right. So any last questions on the do stage? All right, one more before we go into deep dive wise. So that's what we call the share stage. And what ends up happening here is just a routine to get kids to share their thinking and give each other feedback. So what we ask, because every group's been doing their own thing to this point, right? They've developed their own plan, they collect their own data, they made sense of it, they've got an answer to the guiding question. So right now they've moved from trying to figure it out to sharing and communicating their ideas in a persuasive or scientific way. Okay, so they draft these arguments, they share and critique between each other, give each other feedback, and the most important part of the stage is they have to have a chance to come back and revise, fix things. Right, so they're going into this not showing that, not with the mindset that I am right and I am the best one and everybody else is wrong. It's we all have things to improve on. So we're using each other's ideas as building blocks that can improve the quality of all of our work, right? So let me kind of go with the way we do this. So back on the Mexican Wolves in Texas, on their handout, we asked them to move to making an argument. So I usually think of an explanation and an argument as 2 different things, right? So an explanation is what you figured out. In this case, it's usually what we call our claim. right? And your argument is, well, how do you know, right? So to have an argument, you really have to have something figured out beforehand. And then you're using evidence and kind of a justification of your evidence to support whatever you figured out, right? So in order to be convincing, right? So let me give you a couple examples of what that looks like. Couldn't find a picture. I usually snap pictures of all these stuff. I couldn't find one when I was making this for the Mexican wolves, but here's one for another biology example. So in this investigation, they were looking at the biological offspring of two men, right? And so in this case, they have two men, a couple children. Was it child 1, 2, and 3? And they're trying to figure out if any of the three children could be Mr. J's biological offspring or not, right? So when you look at this whiteboard, you've got your claim, which is what they figured out, and then their evidence and their for that and their justification of why they use their evidence. So the way I usually think about this is really thinking about what makes evidence different than data, right? So data is observations or measurements, right? So in this lab, their data would be a result of blood tests, right? So they drop some blood in there, drop some anti-serum, does it clot or not? Okay, so that's the data they have. But to turn that into evidence, you have to do some mental work. So what that usually includes is an analysis of the data of some kind and then an interpretation. And then when you have those two pieces, that's when I think you started having evidence. So I blew up on the whiteboard there. You can see how their analysis is there. So they had their clumping, and then based on the clumping, they said what type it is, right? So they've made an analysis. And then based on that, it's just not enough to say O's and B's and A's. They've got to say, okay, what does that mean for supporting our claim? And then that you can see those bullets down there is what we call their interpretation. Now that's all fine and good, great evidence and those pieces. But the next thing you start thinking about is, why did you use that evidence, right? Why does it matter that we looked at blood clotting? And so what I usually define justification of it as an evidence is kind of your core ideas that you use to kind of frame what data you're collecting, and then any assumptions that you made during your investigation or part of your analysis. So in this case, you can kind of run down their justification. So the first thing they said, blood type's inherited. So if you don't have blood type being inherited, this analysis doesn't work. They had an assumption that the mother carries the offspring, so you know who the mom is. Then their next core idea was the inheritance pattern of how blood type's inherited. So O is recessive, A, B are codominant, right? Their next assumption based on that inheritance patterns was if both parents are O, their offspring can't be A or B. And then finally, the last core idea is each parent has 2 alleles for blood type, but only one's passed down. So these are all the ideas they pulled out from that idea stage in that lab, and then kind of listed those out. And then that allows you to kind of figure out why your evidence matters. Here's another example for Kim. I'm not going to break that down as much, but in this one, this investigation, they were talking over which chemical equation best represents the thermal decomposition of baking soda. So in this case, they had a couple different chemical reaction equations that they could test out. So they said this one is the best one. And then their evidence, then the data they collected was just mass before and after heating up the baking soda. But based on that, they had to do all these calculations and these assumptions. So they ended up with that as being their evidence, right? So they really were focusing on what they would expect versus what they got. And then why does that work? Law of conservation of mass, can't be created or destroyed. So the mass of the product can therefore be predicted from the mass of the reactants if the reaction is known. So they can just lay out that kind of thing. So what you're really hoping there is they understand why they're doing what they're doing into these arguments. One more works for Earth space science just as well. So why does the moon change in a particular pattern over time? In this case, they're developing models. So what they did is they had some data about sunrise and sunset times and what the moon looked like during that over a course of a month. And so what they did here is they built that with one of their model, or they built their model around that data, and then they had another month to check it. So you can kind of see on there what they were saying. Okay, my model looks like that. That's how the moon looks, right? This is where I'm saying this. Does that work on the face? Did that match what my models? So they're doing their kind of predictions to that. And then their justification becomes what were your assumptions when you're making your model, right? So the moon orbits the Earth, Earth spins counterclockwise. These are all the assumptions that we were making when we went into this. So you can see how that becomes your explanation is really dependent on how you know what you know. Now, once they make those arguments, like I usually suggest doing them on some kind of non-permeable surface that makes it easy for them to erase stuff. I like whiteboards. Usually I like to cut like or get a whiteboard that's about 2 feet by 3 feet. Those were those pictures that you saw here of whiteboards. It seems to be about the perfect poster size for easy to see and easy to write on. But the key is it's got to be kind of non-permeable or non-permanent so they can change it. You can also have them do it on Google Slides or anything like that if you want to. But you end up giving then you can give them 3 ways to share their arguments. These are the ones that we recommend. So the first way you can do it is you can do a whole class presentation. So you have each group come up, they give their claim, their evidence, their justification. Then you have time for their classmates to offer questions or critiques, right? I would say this is best when there's only a few groups. So like if you have a small class, right? Like you're running elective or something like that, or you're in elementary space, that's probably the best one to do. The next model you could do is called a gallery walk. So basically at this one is they leave their argument at their station, get up and they move as a group to another station and they read those and then offer written critiques. And then students can keep a record of what went well, went back when they get back to their own argument. And then you could probably only have them go through 3 or 4 rotations on that. So what that ends up looking like is something like this. So like giving kids sticky notes. So they just walk as a group over to somebody else's and then they sit there and add sticky notes of like, change this, add this is great, fix this, right? And then when the group comes back, they can see these and that. The last way you can do it is what we call a modified gallery walk, which means that 1 or 2 members of a group stay and they become the presenters of their argument. So they're going to actually talk through this. The other members of their group are going to be travelers, so they're going to go to other stations and listen. And then the idea is the presenters record feedback that they're given, and then travelers collect ideas to bring back. And what's really nice about this is you get really cool discussions happening. So like the gallery walk, you'll have talking in group about what counts, but you don't get the back and forth with people that have different ideas. And you get some really good ones going with this. So let me show you some pictures of what that looks like. So here's a couple classrooms with modified gallery walks going on. So you can kind of see you've got the whiteboards set up at stations. The people that are closest to the whiteboards are the presenters, right? So they're facing out and talking through stuff. And then you've got other groups there asking questions and talking over stuff. What's awesome about this is you can do this at pretty young ages, right? Oh, that's the same picture there, but the little guys get into this as well, right? So like you can see how just like engaged these kids are as they start talking over stuff and sharing their ideas and pointing out things. Once again, the key is to focus on ideas, how everything gets better, not so much I'm right, you're wrong, that kind of thing. To help them do that on our handouts, what we do is we use this spot. So if you're going around, like if you're doing a modified gallery walk and you're presenting, encourage kids to write down ways that the advice they get. What should I change? What should I fix? Right? Have them write those down. If they're traveling, if they see like a really good graph or a really good piece of justification, write that down and bring it back. And then everyone can kind of talk over what do we need to change? How do we make this better? Does this make sense? And then they can erase their board on those spots and actually change them right there. And then you end up at the end of this with a pretty good product of what this ends up looking like. If you're still allowed to use phones in your classroom, I usually have kids just take a picture of this so they can keep it. If not, you're going to want to store these arguments to the side someplace so they can view them later in a later stage when they're kind of writing up their results. Okay. Questions, thoughts about the share stage? All good so far?
This is the stage I'm most nervous about.
Mm.
My kids, like if I'm going to do it, it's either going to be small group or gallery walk presentations
Yep.
because I don't want them to freak out about having present in front of each other. They're sixth graders. They freak out about it every single time. What are some ways to get them comfortable putting all their information down? Because most of the time my kids try not to write anything down because they think that they can just explain it as opposed to having to put it there and then walk away and have somebody else understand it.
Yeah. So that's the nice thing about kind of bopping between formats. One, it doesn't get stale, right? Like, oh, we do this every single time. So the formats give you two things, right? So the first format of the gallery walk, knowing that no one's going to be there changes how much you write down, right? And you start predicting what people are going to say. The modified gallery walk then does the different ones is I need better visuals, easier things to explain, that kind of stuff, so I can talk through it. And you get to two different mentalities. Either way, the first one is not going to go well for them. They're going to guess wrong on what to put down, like all of us do. I remember when I, in grad school, I went to do my first poster session at a conference like this, and I had no idea what to put down. So what I ended up doing is putting down everything, right? And I had like a little 12-point font, and then I go out to the presentation, and my poster looked like a paper that I had blown up. And everybody else had these great graphics, and they had all these great. No one would come visit me because they just, I'm not reading that, like, right? So it becomes this thing where you have to get used to how do I interact with an audience, right? And part of that's actually one of the biggest practices we have right now in this is learning how to do that. So your first one, what I would probably suggest is I would, if you're sixth graders, you might want to do the whole class first as just a way to get started. And I'll show you a little trick to get good questions happening from that. Then from there, maybe I would then go to the modified gallery walk and let them present in smaller groups. Then move to the gallery walk where they get used to writing more stuff because they'll start doing things like, oh, I need to write this down, or I was expecting to do that. That's the sequence I would go in, but it really doesn't matter. Just kind of bop between those different ones and notice that every time they do it, they'll get better at it. Like by the end of the year, it's amazing how good these look, right? And you don't even have to tell them anything. Just grab your board, make your argument, go get them. And all of a sudden you're seeing all of this great information on there. But the first couple are going to be not good because they're not, like you said, they're uncomfortable doing this. They're not really used to doing it, which means it's going to take a little bit of time before they get there. Any other questions or thoughts? Cool. All right. So let's do a little bit of a deeper dive here right now. So let's see. There's nothing in the Q&A I've seen so far. Is there any topics that anyone wants to discuss in these three, or I'm going to jump in and talk a little bit about arguments? All good?
You mean science topics or topics about this?
About this.
Okay, that's fine.
Oh, yeah. We can talk about science topics afterwards. All right, let's do deeper dives. So how many folks have been like thinking about like CER and things like that, or use CER? Okay, how's that been going for you? Like the find it useful, not so useful?
It's useful because I started with using the data nuggets, which is like not really it's not the same as this, but it's giving them real data and it's
Yep.
got different, I have different options for how much support I give them.
Yep.
So they're having to analyze arguments, but it was when I started making them actually write a summary claim evidence reason, right? That really did need me for some of them. Like some of them found that really easy because they've been doing it in like AP classes or something, but others were like, what does it want from me?
Yeah. What does this mean kind of thing, right?
And I was like, even though I had provided them all these resources that everything we'd been doing had given them all the things to be able to find the evidence based on that claim, they just didn't. And everything I've been giving them really is not that complex. And
Yeah.
once I was giving them examples, they're like, oh, right. But it's like I had given them a lot of the resources to be able to have the evidence, and there's more than one right way to write that claim evidence reason,
Yes.
right? Like you can
Yes.
pick.
Yeah.
They're like, oh, okay, like because I think they were trying to be right,
Of course.
and understandable, but it's also like, no, like science is messy, and
Yeah.
you don't also have to say yes, this claim is supported. You can say it's not supported,
Yeah.
as long as
Which,
you give me evidence and
And
reasoning.
that's part of the thing that they're not used to doing, right?
But it's that fear of not being perfect, and that somehow might affect the grade.
Yep.
So-
Oh no, the fear of grade is hard, right? So like it's really hard to want to take a chance and try something when you think you're going to lose points for it, right? Like we teach kids very young, if you don't do something perfect the first time, your grade's gonna get hit, right? And that becomes an issue on that. So if you take a look on this, so like CERs and things like that, here's a little guy's one. So this is from an elementary classroom. I like to show this just kind of to think about what this looks like in terms of the arguments that we typically use for ADI versus kind of like CER kind of thing. So they're looking at balanced and unbalanced forces acting on a little cart going back and forth, right? So they're hanging different masses off the ends of the cart and trying to predict which way the cart would move or not move at all, right? So when you break this thing down, once again, like I said before, the evidence section is really more than the data, right? So, and kids will come up with some very interesting ways of doing this, right? So this was I think it was a 4th grade class that this was from. So in this case, they were trying to represent how much mass was hanging off of each side. So they were saying, and they were using their math alligator symbols, right? So 50, 50, 500, 100, but they're trying to make these comparisons of things. And then what they were doing is then interpreting. So the greater the number is where the cart went. If the numbers are the same, it meant stay put, right? So that's a really good kind of analysis of what that was meaning. So like that's what they're trying to represent with the 50 equals 50, right? 120 goes to that way, right? Then you start going into the justification of like, why does it matter that you're telling me about masses or those kinds of things? So then they started going back and you actually ask them to reread the idea stage and those useful ideas that they highlighted and what could you add there. So this is what this group came up with. And the teacher was doing an awesome job of like, just underline the things that you used from the handout that we went over and which we're running. So like, they wrote so an unbalanced force is two forces of the same side that have different are same on the same side that have different sizes, right? So they'll talk about that piece and all of these things. So they were kind of laying out all of these things. But the nice thing about the bottom one is that the two pulling forces will be either balanced or unbalanced depending on how much it weighs. So they are connecting like the differences in force based on the size of the masses. Pretty good for 4th graders, I'm always thinking. Now, if you've been doing CER, like that stands for claims, evidence, and reasoning, right? So when you look up how do you define evidence and how do you define reasoning, and that's where kids get stuck of like, what does this mean, right? Often when you read about CER things or on the graphic organizers, you'll see evidence defined as data that supports the claim, right? But the problem is that's just data. And then reasoning is why the data supports the claim. And that's where I really think that's your interpretation, right? So if you take data and you analyze it and you interpret it, you're basically telling us why it supports the claim there, right? So when I think of it on the ADI side, that's why those two are lumped together. Data and evidence are different. You have to transform data into evidence through analysis and interpretation. So you can kind of find that as like, okay, you analyze this and then you tell me what it means. That's your evidence, right? And then we add this last piece of why the evidence matters, right? Why would we choose to use that evidence? Why did we do that analysis? It's getting back to really what we do in science is what's our frameworks that we're using to make sense of stuff on that. So if you looked at these two boards through like a CER lens and an ADI lens, on the left, you'd have your CER would kind of stop at that reasoning, right? So you've got the claim match on all that, but if you're saying like you've got evidence and well, I probably should say that should be say evidence instead of reasoning, but the purple part, that data there would be evidence that supports the claim, right? And then reasoning is why, what connects is that, right? So you can kind of think of CER as that part, and then for the ADI framework where we talk about on this and how we set up the whiteboards and things like that, evidence is that whole left box there in brown where you have analysis and interpretation, and then your justification is in addition to that. One of the things that I have found is really useful for helping kids understand that is defining the evidence and the justification as these two things, right? So evidence is what we know after you collect data. So after you carried out your investigation, that's what you collected data on, right? So that's the information. I started collecting data, I made sense of it, that becomes my evidence, right? Your justification is what you knew before you started doing that. These are all the things that we came into the investigation knowing already, and helps us decide why we collect data in certain ways. And this is tough for kids because very rarely they're asked to really reason through not only why they know how they know what they know, but why is this information relevant, important, of the sea of things that I can choose from, right? And that gets kind of a pretty cool way of thinking about how all of those pieces fit together. Any questions on that piece at all? You're muted, Dina.
My bad. Sorry. I turned on
No,
the
you're
camera
good.
and forgot to turn on the mic. I've
You're
always
good.
felt that CER, like it's fine, like from a thinking point of view, like making them think a little deeply, but it also felt more social science relevant, a little surface.
Yep.
But like my data nuggets, so I'm trying to figure out in my head how to fit this in with my data nuggets because I see cross links there. Most of the data nuggets end with okay, you know this, design an experiment based on
Yep.
this knowledge. Would that
Yep.
that would somehow fit into the justification, or like, what does this mean? How do we use this, right? I just wanted to
Yeah.
make sure I was interpreting that correctly.
Yeah, no, I think that's a good way of doing it. So like anytime you're doing any kind of research, you're going out from a framework or you have something that's already set up, like a given an acceptable way of collecting data on something or acceptable definitions of what this thing is, or like physics is a good example. Are we analyzing this through kind of the work energy theorem, or are we analyzing this through forces, right? So that becomes this kind of like this piece of like, how are we deciding to analyze this situation? That becomes your justification, right? And then based on that, I'm going to collect this kind of evidence or interpret it in that way.
Yeah, just small example. One of my data nuggets, I try to find things that link to my book. I look up topics like with African cichlids. It did like their behavior when they're in a couple but no neighbors.
Mhm.
And then when they're in a couple, and this was real data gathered, and then
Yep.
in a couple with neighbors. And then it's like the next step was like, what questions does this make you ask? What would you think about other animals? What would like, but very open ended.
Yep.
So I was like, that makes me think of using that website. Like if I can find something that relates, even if it's like not direct, but it's
Sure.
related.
Sure, absolutely. All right, other things as we're going through here. Here's some advice of things that you can do for tools for the argumentation session, right? So if you're doing a Gallup walk and you're using sticky notes, one of the things that you can do is use different colored versions of them and then tell them to do different things with those. So like blue might be, I don't know, a glow, right? Or something that they liked. Orange is a question. purple is something they think they should change, and green might be a clarification, some kind of rule, right? So you like 4 kinds of information. And what you can do then with that is then you can say, okay, each group, I'm going to give you 4 of these of each color. When you go around, you have to put 1 of each color on each board, right? And then you go to 4 groups and you have each of those. So it forces them to give different kinds of feedback, right? So, and the nice thing about having the sticky notes like that, where it's those kinds of things, is then they have to offer advice or things that you would change and those things that you add. One of the things that you got to watch out for in any of this is there's a difference between critique and feedback, right? So critique is pointing out an error. And that's often as far as people go, is like, write more. This is unclear. Needs more detail. Those are all critiques, but that tells you nothing about how to make things better. So if you're using sticky notes, the key is you have to tell them how to change it to make it better, right? So on any of those, and that's the nice thing about those, is when you say, okay, this is something you have to change, write down what they have to change, stick it on the board so they can see it. The other thing is, if you're doing a whole class presentation or modified gallery walk, is kids are not used to asking questions about how you know what you know, right? Like, it's just not, we ask them to tell us answers, right? So they'll get stuck. So if, say, you're doing a whole class presentation, you'll see this all the time. This is one of the drawbacks of doing a whole class presentation, is you'll have a group get up there and they'll start sharing those things and they'll start facing you. Wherever you are in the room, next to them, behind them, they'll face you, because they're going to start going, I'm doing this for a grade. And then all the students in the class won't even listen or ask a question. And they'll just kind of go, just sit there and go, whatever, fine. So what you can do is, like, we call these back pocket questions, and they have these questions on there. You can kind of see one here that here's, and they can be anything you want them to be. How does what you figured out make sense based on the phenomenon you watch? Or why do you think your measurements you collected are important? And you can hand kids in the audience, especially if they're younger and just learning how to do this, one of these cards. So give 5 cards out, 1 to 5 different kids. And then those kids are responsible for asking those questions. And what it does is it takes you out of the equation, and the kids are now asking these questions, and then the people are presenting have to respond, but it gives the kids a great scaffold. And what I found is this works really well, that having kind of the poster on the wall where it has samples of questions, because the kids don't look at those, right? But if they have a card, they do. And then you can just pick them back up. It works the same way for the modified gallery walk. If you see like a group of students stop talking, and you can tell they stop talking is because they start looking up or looking around. You just walk over there and you pick one of these cards in the set, and you give it to one kid and you say, ask that question. They ask the question, and then all of a sudden the conversation starts back up again. You just pull the card and then move on to the next group. So this is non-intrusive way of kind of starting the conversation again. So you can do them on index cards or anything like that. It makes it pretty simple to restart those things if you're getting stuck. Last one, if we have time. Well, let's see this. Do you have anyone have any questions on this at all? On like little tools for that? So with that, I got a few more minutes. Hypothesis prediction is something that kids often struggle with as well. And you can see in some of our investigation plans, the reason I bring this up is some of our investigation plans are framed around generating hypotheses, doing a test of that, and then what would be the prediction of that hypothesis based on that test, right? So often, just like data and evidence, kids will use those terms kind of interchangeably. They'll also use hypothesis and prediction interchangeably when they are pretty different kinds of things. So let me kind of give you a format of what I mean by that. So here's just an investigation. You can laugh about it or not, but I come from Washington State. We love our salmon. But the interesting thing about salmon is they are born, they go down the river, They go out to the ocean, spend a number of years there, and then somehow when they're ready to breed, they're able to find the place of their birth and start spawning right there. So people are trying to figure out, well, why? How does salmon find the location, right? How are they able to get back there, right? So a couple of things, a couple of hypotheses that they might have is they navigate by sight, so they look for landmarks and follow that they remember, or they're using smell, which is looking for chemical signals and following that back up to where they ever were, right? So to test those ideas, what you can do is you can take a sample of salmon before they're the mouth of the river, and you can blindfold some of them or plug the nostrils of some and then leave some alone. So you have 3 groups, right? Say 20 of each, and you throw them back in the water, and then you would make these predictions based on that. So if your first hypothesis is valid, right, like they navigate by sight, you would expect the plugged and controlled salmon to make it back, but the blind ones not, because they can't see. Right? Maybe a few might get back, but not all of them. If they navigate by smell, it'd be the opposite. You would see the plugged not make it, but the blind and controlled be fine. So you go back up to that spawning thing, you collect the salmon, and I find that I've got blind and control making back, but none of the plugged. So then I can draw a conclusion based on that is that the navigate by sight explanation is not supported, and the navigate by smell is, right? So like based on my results of my test, it seems to be hypothesis B is what's going on. So that kind of follows the if and then and therefore format. We often ask kids to write in hypotheses, but they struggle with that because the test is missing. And so you've got to kind of think of those pieces. So when we have students write these out for their investigation plan, we're like, okay, what's your hypothesis, potential explanation of what's going on? Your answer to a why question. How can you test that? And then based on that test, what would you predict to see if that hypothesis was actually true or valid, right? And then you can compare that to your results. Now, how that works then when you're talking about an argument is then you can share that. So I've gathered this data here and done this test. I've made these predictions, and I can basically, when I'm moving to an argument, I don't need to tell everybody all this information. That was me figuring things out. That was my investigation. But now I'm communicating what I need to know. So I need hypothesis B and I need my results to be able to persuade somebody that things are going on. So then that becomes a graph. This is what becomes your argument on a whiteboard, right? So salmon navigate by smell. That's what I figured out. Here's my evidence that I'm sharing for you. I'm not doing all of my thinking through this. I'm just showing you that this graph indicates that blind salmon are able to return to their stream of birth, where salmon that can't smell did not make it back. So there's my analysis and my interpretation. And then my evidence, my justification is based on these assumptions. Animals have to use a sense to take in information. So 2 of those, my only 2 senses is probably sight because they have eyes, or smell because they have nostrils. So that's why I decided to test those 2 things. Okay. So you can kind of see how all of those pieces start lining up when we're thinking through these in terms of designing investigations, then carrying them out, and then generating an argument. The big thing to always remember is the argument is not your explanation, is your argument is how you're communicating something. So it's after you figured out everything, now you're just trying to persuade and convince others that what you found out is actually what's going on and not something else. Okay? So with that, what are we thinking about now? Is how are you attempting to make all sense of all this? Do you have any thoughts or concerns you'd like to share? Love to hear from everybody, because it's just kind of nice to know what's going on and where we can go with that. I'll just kind of go down the list on that. Gina, how are things going for you?
Good. My brain's racing because I'm like on the Data Nugget website trying to think of potentially current things, like topics, right, that I might be able to use this resource to think of how to reshape it in a format that
Sure.
might more resemble. So yeah, brain races with thoughts. I've got the other thing that I saw on that thing was vision evolution. On that website, and that very much aligns with things that I cover, and like that vertebrate embryology is something I cover in my zoo. So that makes me very excited to think of, okay, like what, and I already have activities.
Yeah.
They're more paper, but it's like, maybe I could use those and then use that to make them push themselves farther or reverse,
Love it. Love it, love it, love it. Sarah, what are you thinking about how are you making sense of all this? Any thoughts, concerns you'd like to share?
Most of it's going okay. Getting them to put their evidence down is something that I know I'm going to have to kind of push through because they're still learning the process of how to do it.
Sure.
They didn't get a ton before then. And again, just being able to explain their stuff and getting them to focus enough to do their experiment, design their experiment, and then write their data down. That step, for some reason, from 1 to 2, I lose them a lot, and so gotta get that one going.
Yeah. I mean, what is nice about this though is because it's weird. Once they have an audience that's their peers, it's amazing how much they start writing down more and checking and designing better investigations because they get used to the feedback and the critique of like, oh, I don't want to, like, they're going to say something about this, so I got to make sure I write this down, or they're going to say something about trials, so I got to do more than one trial, right? And it's a kind of an organic thing that grows over time within your community of your classroom. It's very much like how you get better at playing sports or singing or anything like that. It's like you go out and do it and then you get feedback and like, oh, I gotta remember this the next time I do this, or no, I can't get beat on this thing, or and you just I think here's another way of thinking about that is the reason like senior scientists are so good at like getting grants and getting papers done versus people that are new is because they've been rejected so many times. Right. So as you go through your career and you start doing science, you're like, oh, I think this will work. And then you get all this feedback like, this is not ready. This is not good. And then all of a sudden you remember all of that for your next time. And then by the time you've done this a bunch of times, you have all of that stuff plugged in and you look like you are an expert at that point because you've gone through and learned from all of those mistakes. So that's always the big one is yeah, I agree with you. The first few times they're going to struggle, but the more
I
you
also
do stuff
am,
like this,
yeah, I'm also worried that if they do struggle to begin with, I might have some pushback. I'm not saying it's going to stop me, but um, a lot of times they get fearful of trying again because I didn't do it perfect the first time. Therefore, I should never test this again, try doing this again. So that's another thing I have to keep in mind when I'm doing this.
coach them up, coach, encourage, right? You can do this. You got this. This is part of it. We're getting there. You're getting better, kind of thing. Devon, what do you got?
I'm a very visual person, so I am wanting to look at like an actual like pamphlet of like the Mexican Wolf one, like first, second, third, like through the steps to see what they see compared to what you're telling us. Because I'm a very visual, like stare at it kind of person.
Got it. Makes sense to me. We'll talk about resources and stuff like that on our last session. Jeff, how's things going for you?
Going good. I'm sort of absorbing and processing all the stuff we talked about. I do like the clarification between CER versus ADI as far as the claim evidence reasoning versus claim evidence justification. So
Love it. And honestly, that's just the way we've been building it for a while, right? So, there's nothing inherently wrong with CER or the ADI version of an argument. So use whatever you find most useful, right? Just the stuff that we tend to make, we'll talk about the evidence and justification in it. So just be aware that that might be on the handout. But if you like CER, go with that as well, right? There's no hard and fast rule on any of this stuff.
okay.
Sean, what do you got?
Yeah, hi. This makes me think a lot about some work that I did a long time ago. We called it model-based reasoning.
Oh, yes.
And it's super similar. Really great way to get kids engaged in inquiry. I think the tricky part is finding the right phenomenon to, drive kids into like what you're supposed to be teaching them about, you know?
Yes.
I
Yeah.
mean, you know, this is great if it's student driven, you know, sort of like um are double stuffed Oreos really double stuffed?
Hmm.
Or, you know, what's the hottest, you know, something that like kids are super motivated to, you know, they get to eat Oreos or eat, you know, hot
Oh, yeah.
chips or something,
Yep.
and they will come up with experiments and collect data and, you know, but okay, so now, you know, we're supposed to be learning about photosynthesis.
Yes. How do we
And
make that appealing?
yeah, so what's the phenomenon that's going to drive us into that? And, you know, how do you hook the kids into getting, you know, like motivated to just sustain, because it's an effort, right? Like to sustain the effort to see through an investigation like this and write about it and revise it and talk about it with their peers. So that's where, like, you know, you gotta try and come up with, you know, I think that's once you do that, you know, all the pieces start to fall into piece,
Yeah.
or all the pieces start to fall into place where, you know, you've got something good and you can repeat it, because the first time you do it with a group of students, it's going to be messy, you
Oh,
know, and
yeah.
they're going to introduce you to all their misconceptions.
Hmm.
And you're going to have maybe a secondary phenomenon that addresses the misconception. Oh, if this is what your model is based on, what if we include this data, another phenomenon?
Yeah.
And then, so then once you do that, you know, and it's like that was your dress rehearsal and now you're ready. So it takes, you know, a couple run throughs to get it really dialed in.
Yeah.
Yeah.
You know, I mean, that's all, the challenges of all of this, right? Getting kids interested, and does this all make sense? And does it, I always worry about also phenomenon becoming just kind of window dressing of this. Like, hey, here's this thing that's interesting. Now I'm going to tell you all the answers. Like really looking at how things are designed and how they all flow together. And I always think whatever you're doing, it always makes sense if every piece then leads to the next question or the next need they have, right? And that's the hardest part about designing stuff, is trying to predict what questions or what's going to make the most sense to them, where they're going to start bringing this up, and hopefully they're interested about it. And that's probably why I try to keep on the investigation screen size, because like if you do, sometimes I worry about if you have a whole unit, right? And your phenomenon of that unit becomes not interesting. I've like, what am I doing for 6 months or 6 weeks kind of thing. So yeah, these are hard, like of trying to figure out, and there's going to be some that are better than others because some of our standards are just much more easy to have investigations or design things around than other ones, right?
Hmm. Yeah. Like Phases of the Moon is a really good one for this.
Yep.
And that's in standards that I've taught before. Yeah. And maybe that's the key, you know, start, you know, ADI using this method with something that's, you know, gonna work, you know, instead of
Yeah.
trying to force it into, you know, like whatever your next unit is, if you can't come up with a good
Yeah.
phenomenon, then wait to try it for something else. And then when you do have something, just jump in
And run with
do
it.
it.
I love it. That's a pretty good way to do that. So, wrap up wise, since we only have 2 minutes left, next time we see each other, we'll do quick thoughts about stages 3 through 5. So, like I'll send you all the video of this. If you have new questions or things that come up, please feel free to reach out. What we'll do then is the last 2 stages, which is kind of the reflect and report. We'll do a deeper dive again. This won't take as long as this one, so I was going to show you some materials that are available, and resources that you can jump into if this is interesting to you, and then we'll do our final wrap up of the sessions. So that's kind of the plan moving forward. I'm kind of impressed with myself getting done right at 5 o'clock. Again, if you need anything during this week, or think of anything, or need something from me, shoot me an email, and I'll respond as quickly as I can and get you the stuff you need. Sound like a plan?
Thanks, Victor.
Cool. Then
Yes,
I
thank
will.
you.
Awesome. I will see you all next week.
Thanks. Bye.
See ya.